Hello dear students, I am Dr. Mrs. Bhute. I am working as a professor in G.H. Raisoni College of Engineering and I teach applied physics. Now today we will try to understand what we will be learning in applied physics in this particular session. So today I will be just elaborating on what and all topics we will be learning and what is their relevance from the point of view of engineering, that why this syllabus has been kept for first year engineering. Now the first unit which we will be learning is electron ballistics and optics. Now as the word suggests, electron ballistics, so it has to do something with electron, right. Now ballistics word is also familiar to you because ballistics is nothing but study of the projectile. What you have learned in your 12th standard is about how a projectile moves under the influence of the gravity. Herein what we will be doing is, we will be learning about the behavior of the electron in electric and magnetic field. So in this particular unit, we will try to understand what an electric field is and magnetic field. So we will try to understand about DC electric field and DC magnetic field and what will happen to an electron when it enters into the electric field or the magnetic field. There are three possibilities the way in which the electron can enter into the electric field. It can move either parallel or anti-parallel to the electric field, it can move either perpendicular or it can move at some angle, either acute or obtuse. So in electron ballistic we will explore what will happen to an electron when it is moving in electric field or the magnetic field. And since it is applied physics, the name of the subject itself is applied physics, so we will try to understand what are the applications of these concepts. Like if I am using electric field for an electron which is moving parallel to the electric field or anti-parallel to the electric field, what I can use this for. So for every case, the way the electron is moving in the electric field, what can be the application, how we can make use of it for practical purposes. So that becomes an application part of this particular topic. So electron ballistics basically covers the behavior of the electron in DC electric field and DC magnetic field and their relevant applications. Similarly, the another word is there, that is optics part. Now optics, again this word is familiar to you. In optics what you have learnt is behavior of light. In this case this is electron optics. So electron optics, basically what we do is, in this electron optics what we learn is what will happen to an electron in a non-uniform electric field, right. So electron ballistic part we will be learning about the uniform fields, and in the optics part we will be learning about non-uniform field. And why this word optics is coming there? Because the behavior of electron is similar to the behavior of light. So it's very simple. So we will be applying all the laws of optics to that of the electron, and again relevant applications. Now you will be surprised to know that non-uniform electric field has lot many applications. Similarly, non-uniform magnetic field also has lot many applications. So we will be learning those related applications. A beautiful application or a wonderful application is cathode ray oscilloscope. All of you have seen cathode ray oscilloscope. So we will be learning what is CRO and what are the applications of CRO, what we can do with the help of CRO, how CRO basically displays the alternating waveforms as it is on the screen. So it is really wonderful to understand the behavior of the electron in the non-uniform electric field and then their relevant application. So the first unit which we will be learning in applied physics is electron ballistics and optics. So I feel that you are now interested in learning more and more about it because we will be learning the applied part. Okay. So this is the very first unit. Now the next unit in the line is related to optics only, and that is interference. Again this word is very much familiar to you, interference and polarization. Right. Now interference is one of the characteristics shown by the light. You already know different characteristics exhibited by light, that light gets reflected or refracted once it moves from one medium to another medium. So that is reflection or refraction. another property which you are conversant with is dispersion, wherein the light it gets split up into different component or its constituents. Then one more characteristic which you already studied is interference, but in this particular subject named applied physics, we will be learning what are the applications of interference phenomena, and basically we will be learning about engineering applications of interference. Now, interference, as you know, it's simple redistribution of the amplitude, right. So, for interference you need two sources, and these two sources needs to interfere, and for interference they need to be coherent. So, all those terminologies which you have learned in previous classes, they are same, but in here we will be putting more emphasis on application of interference, right. So, we will be learning about interference application. So, just to create more interest for this topic, I will just let you know what are the applications. So, the applications like those who are using spectacles, they know that the when you go to a shop, they will ask you whether you want the lenses which are coated with anti-reflection coating, anti-glare it is called, a common man layman's language we call it as an anti-glare coating. So, this anti-glare coating, what it will do? It will delete the error, it will avoid that glare, right. So, how it is done? You have simple glass spectacles, and on the glass spectacles there is a coating, and that coating will get rid of the glare, right. So, this particular coating which are coated on the spectacles, that are based on the interference phenomena, that is you are going to get rid of that additional glare. Okay. Similarly, you must have heard of Ray-Ban glasses, right. So, Ray-Ban glasses, what are they doing? They are keeping your eye safe from what? From ultraviolet rays. So, how ultraviolet rays are banned from entering into your eye, and this is on the basis of the concept which we will be learning in interference. Similarly, interference phenomena has also led to a technology wherein we can have mirrors, right, mirrors which can reflect at certain wavelength. Okay. So, this is a very interesting topic which we will be learning, and more interesting are the application part of it. Similarly, one more characteristic of the light is polarization. Now, what do you mean by polarization? Now, as you know, light is an electromagnetic radiation. Now, electromagnetic, what do you mean by an electromagnetic? Electromagnetic means electric field is continuously vibrating, right. So, if I just draw it like this is an electromagnetic field. Right now, I am considering that this is an electric field vector which is vibrating continuously, and definitely on the x axis is the time axis. So, whenever I have an electric field which is vibrating, it will give rise to a magnetic field, right, and the magnetic field is perpendicular to the electric field, right. So, this is magnetic field. So, what I have is a magnetic field is created because of the changing electric field, right. So, that is why we call light as an electromagnetic radiation, because it has electric field as well as magnetic field. Okay. Now, if I have a light in such coming from an ordinary source like a candle or a bulb or a tube light, these are all ordinary sources like sun. Okay. Now, it has electric field vector vibrating in n number of planes. So, if I just denote it by the vibration of the electric field vector is denoted by an arrow. When a light is coming from an ordinary source, it will have vibrations of electric field vector in n number of planes. I could have drawn number of arrows over here, but then for simplicity I have drawn only few. But I hope you are understanding that it can be represented by a star, wherein I can have number of arrows, electric field vibrating in n number of planes. Now, when this electric field is restricted, that is, if I have something, if I have, let us say I have some crystal, if I make this ordinary light go through it, then if the vibrations of electric field vector are restricted to only one plane, then this light is called as plane polarized light, which is abbreviated as PP light. There is one more synonym for this, and this is called as a linearly polarized light, because the vibrations of the electric field vector are along a line. Okay. So, either you say plane polarized light or you say linearly polarized light. Okay. So, polarization is a phenomena exhibited by light, and what do you mean by polarization? Restriction of the light to only one plane, or the vibrations of electric field vector are only along one line. So, this is what a polarization is. This is the simplest of all, plane polarized light. Then we have circularly polarized light, then we have elliptically polarized light. So, we will be all learning about the different types of polarized light and their related applications. Now again the commonplace applications you all know, wherein it is used in LCD crystals, right. Earlier we had LCD TVs wherein this polarization phenomena was used. That is when the electric field is falling on the molecules, the molecule will rotate the electric field vector, and so a particular light will be transmitted. So you have RBG, red, blue and green color pixels in the television on the screen of the LCD television, right. So a particular color will be emitted because of the orientation of the molecules, the molecule orient because it is polarized, right. So it will be transmitting the light of a particular color, right. So this is a commonplace technology which you have heard of. So we will be learning about polarization. Those who have read a lot, they also know that electromagnetic waves are polarized and they are used in communication, right. And then we have polarides also, okay. So we will be learning about all the applications of polarization in this particular unit, right. So this again continued with an optics part. So we will be learning about the concepts and its engineering applications. Now the third topic in line which we will be learning in details later on is lasers. Now laser again is a familiar word for you. So laser, as it is again an acronym, a short form, and it stands for light amplification by stimulated emission of radiation so every word is important. So herein what we have is laser. What is laser? It is light amplification, right. So the first two letters have been picked up. So light amplification. Now what do you mean by amplification? Amplification means increase of amplitude, but then how are we going to increase the amplitude? One process is responsible, and that is stimulated emission of radiation. So stimulated emission process is augmented or its rate is increased. So we will be learning in this particular unit how a laser light is created. What we know is an ordinary light, but then laser is some extraordinary source. And how it is extraordinary, how it is different from the ordinary light? It is different in so many perspectives. Like laser, as you know, is highly intense, right. You must have seen the laser pointers which are used during presentations. There is a warning written on the laser pointer, that is, do not look into this light. Why it is written? Because that is very powerful, and you must be wondering that the wattage is very less. That laser pointer is only 0.5 milliwatt. See, it is 0.5 milliwatt. Can you just ponder over this? It is milli. Milli means what? 10 power minus 3. Okay. So the wattage is very less, the power emitted per second is very, very less, but still there is a warning written on in bold, and that too on in the red color, that do not look into the laser, right. Do not look into that light, or in different words, do not allow that laser beam enter into your eye. The wattage is very small. On the contrary, if I am an ordinary bulb, ordinary maybe a flash lamp, right, 1000 watt, there is no warning written on there, I can always look comfortably into that 1000 watt bulb, right. So herein I have a laser which is 0.5 milliwatt, but that is very intense as compared to a 1000 watt bulb, right. Now why is it so? So we will be learning the characteristic or the properties of the laser in this particular unit, that why it is called as an exceptional source and how it is produced, right. So as you know that laser is highly intense, it is highly collimated, that is, collimated means laser will always travel in one direction. If you have a torch, right, and if you are aiming the torch on a wall. Now if you are aiming the torch on a wall which is much beyond that, if the distance increases, then what you find out is the width of the aperture goes on increasing, or the diameter of the aperture goes on increasing. On the contrary, if you have a laser pointer and if you point it on an object, then it will form a very fine and collimated. Collimated means a parallel beam, a sharp beam, right. And with that laser pointer, that small pointer, 0.5 milliwatt only, you can point it on a building which is half a kilometer away, right. Why it is happening? Because it is not spreading, the light is not spreading. Light travels as a parallel beam, where in ordinary light it keeps on spreading, right. So this is another exceptional property of the laser which we will be learning. Now how to infuse that property? It is a light only, but then how to infuse those properties in that? So we will be learning the processes which are responsible for giving the laser light, right. And Another interesting thing is we do not have lasers within the visible range, but nowadays we have lasers in the different parts of the spectrum. You have laser in ultraviolet, that is below violet color, you have laser in infrared, that is beyond red color, right. And since again we are learning applied part, so we need to understand what are the applications of laser, why it is an extraordinary source, what are its application. Okay. So, you must be aware about commonplace applications of laser, and what are those applications? Simple application is laser printer you have at home or maybe in the offices, so that is making use of laser. Then you have the computers at home wherein CD writer you have, in the CD writer semiconductor laser is used, right. So, there are some commonplace application which come across. Also you must have heard of laser shows, right. So, nowadays laser have also come into an entertainment industry wherein lasers find application. Apart from this, you must have seen hoardings where it's written that is from some hospitals that laser surgeries are undertaken. So, laser is also used in medical field, lasers have utmost use in the engineering field as well. It is used for machining purpose like for drilling, cutting, right, welding, as well as laser is also for used for ranging technique, right. Some other uses are also there for laser like destruction purpose, right. So, there are n number of applications, you can Google it and you can find it out. So, what we will be learning in this particular subject is what are the basic concepts, right. So, what are the properties of laser and how these properties laser light gets. So, what are the processes which are responsible for making it exceptional. So, this is what we will be learning along with the application part. The fourth unit which we will be learning is about quantum mechanics. Now, again this is a wonderful unit which we will be learning. Again the introductory part is done in your low classes, like quantum mechanics, quanta word you are already familiar with, you have learnt a little bit of quantum mechanics in your 12th standard, and that was nothing but when you gave explanation for photoelectric effect, right. So, in that case you have learned about little bit of quantum mechanics, right. Now, what is this quantum mechanics? Okay, what you have learned up till now is Newtonian mechanics, right, wherein you had all those Newton's laws, right, that is B is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus twice AS, those are all Newtonian mechanics or kinematic equations we say. So, that gives us a behavior of the body under the influence of any force, right. In quantum mechanics it is a totally new mechanics, and this mechanics is basically for the objects which are in the atomic world. So, this mechanics basically applies for atomic particles. Now, what are the atomic particles? The atomic particles are like electron, proton, neutron, or there may be some ions, right. So, atomic particle trapped in atomic surrounding. So, these words are very important, atomic surrounding. So, our Newtonian laws will not be applicable for the particles so small like electron, wherein the mass is 10 power minus 31 of a kg, right. And if that electron is trapped in a surrounding which is of atomic size like 1 Armstrong, 2 Armstrong, for simplicity let us try and understand an electron is within an atom. So, we cannot use Newtonian laws to find out the behavior of the electron. Now, what do you mean by behavior? Behavior means simply two things. The first thing is its position, where the electron is likely to be found out, and the second thing is what energies it can have, right. Energies below, else you can say velocity or momentum, right. So, two things are very important, that is if I need to know the particle, then I need to know its behavior. What do you mean by behavior? What kind of positions it can have and what kind of energies it can have. But if I have a particle which is of atomic size and it is trapped in an atomic surrounding, then I have to use another mechanics, and that we call as quantum mechanics. This mechanics is relevant, or this mechanics is applicable only for atomic particles in the atomic surrounding, right. And we will be learning applications of quantum mechanics as well in this particular unit, right. And the fifth unit is about semiconductor physics. So, again this word is familiar to you, but then we will explore more applications of this. So, semiconductor physics, as the name itself suggests, that we will be pondering more on this semiconductors, we will be learning more about the semiconductors. You all know that if I have any material, then what we do is we classify them based on their different properties. Like there can be physical properties, there can be chemical properties, there can be electrical properties. In applied physics, we will be giving more emphasis on the electrical characteristics, right. So, when I have a material and if I connect it in a circuit, let us say I have a block and I connect it in an electrical circuit, like if I give a voltage and if I have a current meter over here, right. So, this is called as an electrical characteristic. So, if I want to find out how this material will behave under the influence of some voltage, that means I have applied an electric field. There is an electric field which will be created over this block, I do not know this block. Okay. Now, from its electrical behavior I can find out what is this material. It can be a metal. When will it be a metal? When I have a huge current, right. For a small voltage, if I get a huge current, let us say this is a variable power supply. So, if I increase the voltage little bit, I get a current in the circuit, right. Now, if I replace this material, this particular block by some other block, okay, I am increasing the voltage, there is no current. So, what you will call them? Yes, you can call them as bad conductors of electricity, or you can call them as an insulator. And in some cases what you have is voltage applied, current increases, but not as high as metals, not as low as the insulators. So, we classify them in semiconductors. Now, this is a very, very important material, because what you can do is you can manipulate their conductivities, right. So, this class of materials are very important, because by doping, what do you mean by doping? Addition of impurities, right. Do we add impurity? We never add impurity. We want a material to be pure, 99.99% pure. But in semiconductors, deliberately we add impurity. What is the motive behind it? To manipulate its conductivity. So, what we do is we can change the conductivity of the sample by making it impure, but then that impurity which we add is in a very controlled amount. What we say is part per million, ppm. This again word you have learnt, right. So, part per million. So, this is what we do, we add impurity in the semiconducting material, and this is how we can change its conductivity. And if I can change its conductivity, I can use it for the desired application. So, by using this technique, what we get is an n-type semiconductor, p-type semiconductor, and wonderful devices are created when we join p-type to n-type semiconductor, right. So, what we will be learning in this particular unit is what are the semiconductors, what is the mathematics which governs the semiconductor, right. And next thing what we will be learning is about the devices which we can make out of the semiconductors, right. Like n-type semiconductor you already know, p-type you know. So, what we will be doing, we will be going a level ahead, what we say, we will try to understand more about the devices which can be manufactured out of semiconductors and what is the use of all those devices, right. So, that becomes semiconductor physics, and the 6th unit is advanced trends. Now, in the advanced trends, what we will be doing is, we will be learning something new, right, or a little higher version of whatever we have learned. So, in this case, in advanced trend, what we will be learning is about carbon nanotubes, right. This is a very in topic, a very latest topic. Okay. This comes under the discipline of nanomaterials, right. So, nowadays this is a buzzword now, that everything, the size of everything is going down and down, it is coming to a very small size and plus increase in the efficiency. Now, how is it possible, right? You all have cell phones, the size of the cell phone is reducing, the weight of the cell phone is reducing, but the efficiency is increasing. Earlier it had only few functions, now the functions are multiplying, right. Now, how is it possible? It is only possible by changing the material by which the components were made up of, right. So, this comes under materials engineering. So, we need to know about what is the advancement in the field. So, we will be learning this particular topic, that is carbon nanotubes, under this head, wherein it is an advanced trends. Okay. So, we will try and learn what are the nanomaterials. Now, what do you mean by nano? Nano means what? Nano is nothing but nanometers. If I write down, nanometers is nothing but 10 power minus 9 of a meter, right. So, nano is 10 power minus 9 of a meter. That means we have come down to an atomic size. If I want to write it down in Armstrong, how much it will be? It is, it will be 10 Armstrong, right. So, if I multiply it by 10 and divide it by 10, if I divide it by 10, this becomes 10 power minus 10. So, this becomes 10 Armstrong, right, because one Armstrong is 10 power minus 10 meters. So, again I have come down to an atomic world, wherein again quantum mechanics will be applicable, right. So, nanomaterials are the materials wherein one of the dimension, if you have a material, let us say this is this is made up of nanomaterial, right. Now, how can it be made up of nanomaterial? Because one of the dimensions should be of nano size. So, if I have this kind of tube like structure, then either the diameter should reduce to a nano size or the length should reduce to a nano size. The ideal thing is its diameter should reduce to a nano size. If I have a block, then one of the dimensions should reduce to a nano size, right. Either it can be drawn into sheet wherein the breadth of the sheet will be as, maybe it will be macro size, okay, ordinary size, but in the thickness of the sheet will be of the nano size. So, that can be called as a nanomaterial, right. And in nanomaterials, we have absolutely different characteristics of the material, right. The material will behave in a different manner, right. You will be astonished to know that metals, when they are manufactured in nano sizes, they become semiconductors, right. The gold, which is of yellow color, when it is manufactured in nano size, again I hope you are understanding nano size, that is the particle size will go on reducing, right. Okay. So, particle size means a particle is made up of so many atoms or molecules, right. So, what you do is you have less number of particles, the radius goes on reducing, okay. So, a gold, if it is manufactured in nano size, it will look red, right. So, maybe after 10 years or so, we will be wearing the gold which will be of red color, right. So, why this field is fascinating? Because what we can do is we can manipulate the properties of the material without distorting it, without reducing its efficiency, or the contrary, we elevate the efficiency, right. So, this is what we will be learning in applied physics, and the course outcomes will be like electron ballistic, we will try and learn about the electric field and its application, relevant application. Interference and polarization, we will be learning about the concepts and its relevant application. Similarly, lasers also, we will be learning about the concept and relevant engineering application. Quantum mechanics, the mechanics which is at the atomic level and its relevant application. Semiconductor physics, devices which are based on semiconductors, and advanced trends we will be learning about the carbon nanotubes, which are nothing but the one of the types of nanomaterials which we have. So, this is what we will be learning in applied physics unit wise. Thank you.